Hello, welcome to this session. My name is Shian Nafti. In the next few minutes, we're going to explore deploying an application, the Cyclos mobile application, onto the Google Cloud platform. We're going to deploy the Cyclos application into a Kubernetes cluster hosted and managed by Google. Let's get started. We're going to start off by enabling access to the Google Cloud services that will be required by our Cyclos application. Next, we're going to create a network for our Kubernetes cluster, which will host our application. We're going to create the network as a custom mode network. Having created the network, we're now going to create a subnet for this network. We're now going to create a peering IP range for accessing resources deployed onto the network. Let's connect the peering IP range to the custom mode network. With the network in place, we're now going to move on to the database configuration. We're going to start off by creating an instance for our Postgres database on the private network we created earlier. Having created the instance, we're now going to create a cloud storage bucket for our backups. Let's enable versioning on our cloud storage bucket. Let's define the lifecycle configuration for our cloud storage bucket. Let's enable the lifecycle policy we just configured. Let's authorize access to our network in order to create our database. Let's create a database user for the Cyclos application. Let's create a database for the application within the instance using the character set of UTF-8. Let's disable access to the network from our Cloud Shell console. With the database configured, let's move on to step number 4 and configure the Kubernetes cluster. Let's create the Kubernetes cluster in the US Central 1A zone. Let's retrieve the cluster's credentials. Let's grant administrative privileges to the current logged-in user. Let's create a service account for Tiller. Let's grant the Tiller service account administrative privileges on the cluster. Let's initialize Tiller. Let's create a custom node pool for the cluster. Let's cordon off the nodes within the default pool. Let's drain workloads from the default node pool. Let's delete the default pool. Before moving to step number 5, where we're going to configure the cert manager, let's return to our Google Cloud Console and explore the configurations we've performed so far. To do that, we're going to navigate to the networking section, select VPC Network and VPC Networks. You can see here the private network we created in step number 2. The private network was created as a custom mode network. We then configured a subnet in the US Central 1 region and specified an IP address range for that subnet. Let's explore the Cloud SQL configuration. To do that, we're going to navigate to the storage section and select SQL. You can see here the Cloud SQL instance that was created. The instance was of the type Postgres SQL version 11. We created a private SQL instance, and you can see here the private IP address. Also displayed is the instance connection name. Let's navigate into the instance and explore the configuration further. On the overview page, we can view high-level information on this instance. Let's have a look at the Connections tab. Here we have confirmation of the fact that this is a private instance. Let's navigate to the Users tab. Here we can see the Cyclos database user that was created earlier. And under databases, we can also see the Cyclos database that was created earlier as well. Let's explore the Kubernetes cluster. To do that, we're going to navigate to the Compute section and select Kubernetes Engine Clusters. Here we can see the Cyclos cluster that was created in the US Central 1A zone. We enable autoscaling, minimum of 2, maximum of 8 nodes. We currently have 3 nodes in the pool. On the details page for the cluster configuration, you can find additional information on the cluster. And right at the bottom, we have confirmation of the Cyclos pool that was created. Here we have the version, 3 nodes, and we can also see here confirmation of the auto-scaling configuration. Let's navigate to the Workloads tab. And as you can see, currently there are no workloads deployed. Let's move on to the next section, section 5, where we're going to begin the process of configuring workloads within our Kubernetes cluster. Let's navigate to our Cloud Shell console and perform step number 5, during which we're going to configure the certificate manager for SSL. We're going to configure SSL using Let's Encrypt. Let's Encrypt enables us to generate and manage SSL certificates within a Kubernetes cluster. Let's start off by adding the Helm repository. Let's update the repository cache. Let's create a namespace for the certificate manager. Let's label the namespace to disable validation. Let's configure the custom resource definitions. Let's configure our cluster issuer using the Let's Encrypt staging configuration. In the next step, we're going to install a certificate manager in the cert manager namespace. Let's return to our Google Cloud console and explore the certificate manager configuration. Let's navigate to the Workloads tab. You can see here the certificate manager deployments. We have 3 deployments in the cert manager namespace. Let's take a look at services and Ingress. And here we have 2 services of the type cluster IP. Let's return to our Cloud Shell console and proceed with step number 6. In step number 6, we're going to configure our Ingress controller. Let's create a regional IP address in the US Central 1 region. Let's set the regional IP address as the load balancer IP environment variable. Let's create the namespace for our Nginx Ingress controller. Let's configure our Nginx Ingress controller in the Nginx Ingress namespace using the regional IP address we created previously. Let's return to our Cloud Shell console and explore the configuration for our Nginx Ingress controller. Let's navigate to the Workloads tab. Let's filter namespace and select Cert Manager. You can see here the 3 deployments for the Cert Manager. Let's navigate to Services and Ingress and also filter by namespace, Cert Manager. And here you can find a couple of services of the type cluster IP. Let's return to our Cloud Shell console and carry on with the next step. Having configured the Ingress controller, we're now going to proceed and build our Docker image that is the container for our Cyclos application. Let's start off by creating a zip file of our Cyclos application code. Having customized and packaged the application code into a zip file, we're now going to create a container image for the Cyclos application. Let's configure Docker to use gcloud as a credential helper. Let's tag the image we've just built for Google Container Registry. Let's push the image into Google Container Registry. Let's navigate to the Tools section and select Container Registry Images. You can see here the Cyclos image. Visibility is set to private. Let's click on the image. And here we have confirmation of the version, and this was created 1 minute ago. Let's return to the Google Cloud Console and resume our configuration. In step number 8, we're going to configure service accounts and secrets required for accessing data from our Cloud SQL database. Let's create a Cloud SQL service account for accessing the database. Let's grant the Cloud SQL client role to this service account. Let's download the JSON key for the service account. Let's create a namespace within the cluster for our Cyclos application configuration. Let's create a generic secret for our Cloud SQL instance credentials using the JSON key we downloaded previously. Let's create a generic secret in order to make the database username and password accessible from within the cluster. Having created the service accounts and secrets, let's move on to step number 9, where we're going to configure our application. We're going to start off by creating a service for our default HTTP backend. Next, we're going to create a deployment for our default HTTP backend. Having configured the backend service and deployment, we're going to move on to the configuration for the Cyclos application. We're going to start off by creating a config map for the application environment variables. Next, we're going to configure a headless service for the Cyclos stateful set application. Having created the headless service, we'll now configure our Cyclos stateful set application. Let's configure an Ingress service in order to enable external access to the application. We're going to create an ingress using a custom domain from the xip.io service. Before accessing the application, let's return to the Cloud console and explore the configuration we've performed in the last few steps. We're going to start off by navigating to IAM and admin, and we're going to select IAM. You can see here the service account for Cloud SQL. That's the Cyclos Cloud SQL account, along with the role of Cloud SQL client. Let's navigate to service accounts. Here you can see the email for the Cyclos Cloud SQL service account, along with the ID for the key that was downloaded and configured as a secret. Let's navigate to the Kubernetes engine and view configuration. This is the secret we created for the database. This secret enables us to have access to the username and password for the database from within the cluster. We also configured the Cloud SQL instance credential secret. This enables us to have access to the JSON key for the Cloud SQL service account from within the cluster. And finally, we configured the Cyclos config map. The Cyclos config map enables us to specify environment variables such as the members of the cluster for Hazelcast, as well as the database host, database name, and database port. Let's navigate to workloads and explore our application. You can see here the Cyclos deployment as a stateful set, as well as the default HTTP backend as a deployment. Let's have a look at services and Ingress. In the Cyclos namespace, we have 3 services. We have here the Cyclos application service. This is a headless service. We also have the Ingress service that was configured using the custom XIP domain. And finally, we have the default HTTP backend, which was configured as a cluster IP service. Let's access the Cyclos application using the custom domain. The Cyclos application was configured using a self-signed certificate, so we need to accept to proceed. And you can see here the Cyclos application loading. Let's allow a few seconds for the registration page to be displayed. This is the Cyclos license server authentication page. Thanks for watching this video.